Hello and welcome to the Writing Exponential Equations from 2 Points video. In this video, we're going to take a look at tables, at ordered pairs, at graphs, and the Go Formative will have story problems, all dealing with, hey, here's 2 points, or maybe more than 2 points, how can we write an equation? Specifically, an exponential equation or function. Now, when we're taking a look at an exponential function, we're going to write it in the form of y is equal to a times b to the x. Now, this x and this y, those are the points we're going to be plugging in. A right here, that's our, not a great arrow. There we go. You can think of that as your start value or your y-intercept. And then b is the multiplier or your pattern. So just a reminder, linear functions, you're adding or subtracting the same thing the whole way through, whereas exponential functions, you're either multiplying or dividing by the same thing the whole way through. Now, because of that, we're usually multiplying by something. We're going to find our equations by dividing two entire functions. Just kind of like with elimination, how you would add or subtract two functions to take out one of the variables. We're going to do the same thing, but with division. So let's get started and take a look. Now, if we scroll down just a little bit, everything is numbered just kind of cattywampus. Everything was kind of mishmashed from a few different worksheets. But if we take a look on that first page to that problem 5, we have a table right here. Now, we have 1, 2, 3, 4, 5 points. We can pick any 2 of these points that we want. I usually like to pick points that are close together, and usually with the smallest x values. So I'm just going to pick the points 212 and 448. So what I'm going to do is I'm going to write out both of these points into our equation, starting with the one with the highest x value. So if we normally have, oops, that's still a highlighter. There we go. So if we normally have y is equal to a times b to the x, in this case my y is going to be 48 is equal to a times b to the power of 4. So again, I'm starting with my highest x value first. I've plugged in everything that I know. I don't know a, I don't know b. We'll solve for those in just a moment. But now if I try it with my second point just underneath it, we'll have 12 is equal to a times b squared. Now, just like I said, when we're dealing with elimination with linear functions, we're either adding or subtracting. In this case, we're going to divide everything. So we're going to go through and cancel out everything that we can. So let's see what we get as our answers. First, we'll divide our y's. 48 divided by 12 is going to give us 4. Then we'll have an equal sign. And we have a divided by a. Here's the thing. I have no idea what a is. We haven't solved for that yet. But I do know that anything divided by itself is just going to be 1. And since these a's are coming from the same table or the same equation, I know these are going to end up being 1. So we can just cancel those out right away. Lastly, we have our b's. We have b to the 4th divided by b squared. Now remember, when you're dividing two numbers of the same base, you're going to subtract their exponents. So this is going to leave me with b to the power of 4 minus 2, or 2. So by dividing those two equations, we were able to just get b on one side and a number here. Now you'll notice we still have an exponent. We have to deal with that. In this case, we have a squared, so I am going to square root both sides. And we're going to get b is equal to 2. Now normally when we square root something, we want the positive and negative version. In this case, when we're solving for exponential functions like this, I'm only going to ask for the positive version. So we know that b is equal to 2. Now what we're going to do is we're going to take our value and plug it back into one of these equations. It does not matter which one. I usually tend to go for the one with the smallest exponent just because my numbers end up being a little bit smaller. So let's see. So if I was to plug that back in, we're going to have 12 is equal to some a value, we don't know what, times 2 squared. So again, whatever number we find for b we're going to plug that into our equation here and solve. So we end up with 12 is equal to, let's see, 2 squared is 4, so 4a. And to get a by itself, I'm going to divide both sides by 4. And I get a is equal to 3. So if I'm going to rewrite my whole equation in this y equals a times b to the x form, I'm going to keep my y and my x just as they are, because we can have any x value and any y value. But my final equation is going to be y is equal to that a value of 3 times our b value of 2 to the x. And there you go. So again, remember, whatever your highest x value, that goes on top. If you put the lowest x value on top, it'll still work out. It'll just be a lot more complicated because we'll end up with negative exponents. But this is what we're going to do every single time, whether it's a table, ordered pairs, graph, story problem, you name it. But let's try with one more table before we move on to something else. So let's see, if we move on to the beginning of the next page, the one that says problem number 3, oops. If we move on here, so we can see again, we have some more points. You can pick any of these points. I'm going to choose the ones with my lowest x values. And remember to put, when you're ordering your list, put the one with the highest x value on top so that your final exponent ends up being positive. So let's see, this will end up being 1228.8 is equal to a times b to the 4th. And then underneath that, we're going to have 1536 is equal to a times b squared. And again, we want to divide that whole thing and see what we get. So sometimes we're going to get nice whole answers or whole numbers like we did in the previous problem. Sometimes we'll get some really messy stuff. If you get messy stuff, round to the 4th decimal place. So let's keep going. So if we take our y values, 1228.8, divide that by 1536, we end up with 0.8 is equal to a divided by a, which cancels out, and b to the 4th divided by b squared. Remember to subtract those exponents, so we end up with a b squared. So to get b by itself, we're going to square root both sides, and we end up with something super duper decimally, again, round to the 4th decimal place. So we'll end up with 0.8944 is equal to b. Now this b value here, it does have a longer decimal. Please make sure to keep that longer decimal in your calculator so that when you're finding the a value, you can use that longer decimal. So again, we're going to take this, plug it back into one of these equations. I'm going to plug it back into this bottom one for 2 reasons. One, it has a lower exponent, which I prefer. But I also know that if we just took 0.8 and took the square root of it, we're going to get this long decimal. But that also means if we take this long decimal and we square it, we're going to get 0.8. So I kind of know what we're going to deal with. So let's see, we'll have 1536 is equal to a times 0.8944 to the power of 2. So again, our b value goes right here in our equation. We'll plug this into our, well, we should hopefully already have this long decimal. Keep that in your calculator. Just take that answer and square it. But we should know, we should get 0.8. So we'll have 1536 is equal to 0.8a. We'll then divide both sides by 0.8. And we'll get 1920 is equal to a. So now that we have our a value and our b value, our final equation for this problem is y is equal to 1920, or our start value, times our multiplier of 0.8944 to the power of x. So the last 2 examples we've done both deal with tables. We're going to be doing 2 more examples, one with just some ordered pairs, the other with a graph. So let's keep scrolling down on this same page. In these next problems, it says, given the 2 values from an exponential function, find the integrated equation. So if we take a look down here where it says problem number 8, it doesn't actually give it to us in a coordinate pair. It says f of 2 is equal to 5 and f of 6 is equal to 20. Well, remember, whatever is inside those parentheses, that's an x value, and whatever it's equal to is a y value. So these are actually the points 2, 5 and 6, 20. And once you know that, it's exactly the same type of thing that we were doing before. So let's keep on going. Let's try that once more. So remember, on top, we're going to put the equation with the highest x value. So in this case, it's going to be 6. So we will have 20 is equal to a times b to the power of 6. And underneath that, we'll have 5 is equal to a times b squared. So we're going to divide this whole equation and see what we get. So 20 divided by 5 is going to give us 4, then equal to. A divided by a, anything divided by itself is 1, so that's going to go away. And then we have b to the 6 divided by b squared. So when I subtract those exponents, b to the 6 minus 2, or we get b to the 4th. Now, just like we did with our other problems, we want to get rid of the exponent. But instead of taking a square root, we are going to take a 4th root. I can show you how to do that in the calculator. You can also put this to the power of 1/4 if that works for you. But once you plug this into the calculator, you get 1.4142 is equal to b. So remember, round to the 4th decimal place. And then we're going to take this number, plug it into either of these equations. I'm going to plug it into the bottom one so that we end up with 5 is equal to a times 1.4142 squared. So whatever our b value was here, that's what we'll plug in here. Now when we take this number and we square it, make sure to keep that decimal in your calculator. Because when you take this super long decimal and you square it, you actually just end up with 2. So we end up with 5 is equal to 2a, so much nicer. Then we'll divide both sides by 2. And we get that a is equal to 2.5. So both decimals, one not as gnarly as the other. When we plug this into our equation, we get y is equal to our a value of 2.5 times our b value of 1.4142 to the x. Do not forget that x. So again, same type of math, just different type of situation. Let's try this once more. So if we come all the way down to our graphs, there's 4 graphs in the Go formative. However, I only have 3 here. Oh, there they are. We're going to be doing problem number 8 again. So again, I know these are all worded or numbered terribly, but it's a mishmash of things. If we take a look at the instructions from this page, it says for each graph, identify 2 points that you know for sure, no decimals or fractions, then use the same strategy to write the equation of the graph. So it's just what we've been doing, but we want to make sure that we choose nice points. So if we come to here, I may look here and be like, oh, that's about halfway, but I don't want any abouts. I want some exact things. So from here, there are a few points we can choose from that are exact. The first 2 that I see are right here at 0, 2, and up here at 1, 6. So those are the points I'm going to use. There's my x and y values. So let's get started. So remember, highest x value on top. So we'll have 6 is equal to a times b to the power of 1. And then we'll have underneath 2 is equal to a times b to the 0. So you can have 0 as an exponent. That's totally fine. We want to divide these 2 functions and see what we end up getting. So let's see, 6 divided by 2 gives us 3. A divided by a becomes 1. B to the 1 divided by b to the 0, when we subtract those exponents, we get b to the 1 minus 0, or just b to the 1. And when you have an exponent of 1, that's kind of just like not having an exponent there at all. So this is b is equal to 3. Kind of nice when it works out that way. So we'll take this, we will plug this in to one of our equations. I know I usually do the bottom one. I think I'm actually going to do this one up here just so I don't have to deal with that exponent of 0. But I'll plug this in here. So we have 6 is equal to a times 3 to the power of 1. So again, our b value here goes in here. 3 to the power of 1 is just 3. So 6 is equal to 3a. Divide both sides by 3. And I get a is equal to 2. So when I write out my final equation, I get y is equal to 2 times 3 to the x. So again, some problems end up being nicer than others, but that's okay. It's the same process each time. If you take a look at the Go formative for this material, there is another method shown which you are very much allowed to use. I just find this one tends to go over a little smoother. So thank you for watching this video. Let me know if you have any questions. I look forward to seeing you tomorrow.